Hello students, now we will discuss height of stationary satellite of Earth. Now height of satellite, suppose this is a Earth with center O, mass m and radius capital R. Let a satellite of mass m is revolving around the Earth with orbital velocity v0 in a orbit at a height h. Suppose this is the orbit around the Earth at a height h from the surface of Earth. Let this is the planet satellite. This is a satellite of mass m and revolving with velocity v0 in the orbit like this. Satellite of mass m is revolving around the Earth with velocity, orbital velocity v0. Now time period of satellite is given by capital T is equal to 2 pi into under root r plus h whole cube upon gr square. Put this equation number 1. Now squaring both sides to remove square root. So we get t square is equal to 4 pi square into whole square of under root r plus h whole cube upon gr square. Now square and square root cancel each other. Therefore we get t square is equal to 4 pi square multiply r plus h whole cube upon gr square, or by rearranging r plus h whole cube is equal to g into t square r square upon 4 pi square. So to remove cube, taking cube root both sides, so we get r plus h is equal to g t square r square upon 4 pi square whole power 1 by 3. That is r plus h is equal to g t square r square upon 4 pi square whole power 1 by 3. Now taking capital R to the right hand side, or by rearranging, we get h is equal to g into t square r square upon 4 pi square whole power 1 by 3 minus r. Put this equation number 2. So by this formula we can find the height of the satellite if we are given the time period of the satellite. Now height of stationary satellite. First, stationary satellite, the satellite which appear to be stationary when observed from the Earth is called geostationary satellite, and the orbit in which the stationary satellite revolves is called stationary orbit or parking orbit. So in the parking orbit, any satellite appear to be at rest when we observe from the earth. Now for the stationary satellite, the following conditions should be satisfied. First is, it should revolve in an orbit concentric and coplanar with the equatorial plane. That is, the parking orbit, plane of parking orbit must pass through the center of earth, or it is along the equatorial plane. Number 2, its direction of rotation should be same as that of earth about its own axis of rotation, that is from west to east. Third condition, its time period of revolution around the earth should be same as that of earth about its own axis of rotation, that is it is equal to 24 hours. Now from question 2, the height of the satellite of time period capital T is given by h is equal to g t square r square upon 4 pi square whole power 1 by 3 minus capital R. Now for the satellite to be stationary satellite, the time period capital T must be equal to 24 hours, where capital R is the radius of the earth and is R equal to 6400 kilometer is equal to 6400 into 1000 meter, or it is equal to 6.4 into 10 power 6 meter, and the acceleration due to gravity on the surface of earth is g is equal to 9.8 meter per second square. Now for stationary satellite, the time period of revolution around the earth should be same as that of earth about its own axis of rotation. Therefore, capital T is equal to 24 hour and is equal to 24 multiplied by 60 multiplied by 60 second. Now put these values in the above equation. Therefore, the height of the stationary satellite is given by h is equal to gt square r square upon 4 pi square whole power 1 by 3 minus capital R. By putting the values of g, capital T and capital R, we will get h is equal to 9.8 multiplied by 24 into 60 whole square multiplied by 6.4 into 10 power 6 whole square upon 4 into 3.14, the value of pi whole square, and the whole power is 1 by 3 minus the value of R 6.4 multiplied by 10 power 6. So solving this, we can find h is equal to 3.593 multiplied by 10 the power 7 meter, or is equal to 3.593 multiplied by 10 the power 4 kilometer, or is equal to 35930 kilometer, and also h is approximately equal to 36,000 kilometer. Therefore, the height of the stationary satellite is approximately equal to 36,000 kilometer from the surface of Earth. So by this formula, we can find the height of satellite or height of stationary satellite. So thank you very much.